Alright, so I was just implementing my own if. Now I say I can use that if. Yes, I can use it if. Say, for example, loop. That would be an infinite loop. Say okay, returns okay. Then we say evaluate my if. I don't have. Yeah, evaluate my if. Yeah. Yes. Ja, sehr gut. Ja. Loop and then okay. Makes okay. Doesn't go into the loop. It's important. Didn't evaluate that part because we say atom here. Okay. Yeah. Very cool. This is impressive. They also kind of say it here a little bit like, yeah, here this is something impressive. Usually you have this as a compiler thing or an interpreter thing, but here some programming languages, so yeah, that as well, typically requires a special treatment in interpreters or compilers to avoid evaluation of branches not triggered by the condition. Kind of flexing the muscles that here we have this separate. We can say to the interpreter, don't evaluate these, and basically I'm a normal function. I just look like a normal function. And it's a normal function. I think it's a normal function, more or less. You can ask for the type and you will get the answer if you say get type. It's interesting to see which ones have the type atom, because those are not evaluated, so this is kind of relevant. If you comment out the type definition, then the program will go into an infinite loop. That's true, because then my if would just be a function. Yes. Lazy model of computation could automatically postpone evaluation of then and else expression until they are not required. But this is currently not implemented. Yeah, this would be basically like in Haskell, where everything is lazy by default, where everything only gets evaluated the moment you look, the moment you need it. Okay, but this doesn't do lazy evaluation. This does applicative evaluation, I think this is called. So for all the arguments of a function, we evaluate the arguments before the function is run, except if the type is atom. You can imagine how a sequential AND function can be written, which evaluates its second argument only if the first argument is true. Let's think about that. Okay, so colon, seek, and that. How would you write? What would you write? You would write seek and foo bar her der or something like that, right? This would need to be its second argument. No, wait, it only has one argument. Okay, so foo bar, seek and foo bar. Yeah, this is a little bit like closure sum or something. This is a little bit like that, or just and. Actually, isn't it like and in closure? Yeah. Okay, so it evaluates the first thing, so that should be bool, right? It always evaluates the first thing, must evaluate the first thing. It evaluates its second argument. So yeah, only if the first is true, yeah. And the second argument is atom, and the return type is bool. I see, that's what I go for. Okay, so like that. Yeah, this is, yeah. Then you implement this. So seek and takes a predicate and a consequence, and then it, let me think. Wait, we do it. This is so cool. Wait, this is so cool. This pattern matching stuff allows us to say it like that, and we say, we don't even talk about the predicate. We just talk about sort of the base case, because the evaluator is going through the predicate and reduces it to a boolean. So we have this thing here. So now true then is the consequence, and else it's nothing. So wait, one sec. Is the consequence something that returns a bool? Which evaluates its second argument only if the first is true. Yeah, okay, I guess this assumes that this is returning a bool, I guess. Okay, so here I can say false. I don't even need to. Yeah, we kind of see that we skip evaluating this consequence completely. And yeah, in order to have this special behavior, we need atom. We need to say atom here. So consequence is now this special thing. So this is a little bit more like a macro now. Yeah, like this. I think this is correct. Loop is a function that takes a bool and returns a bool. Sounds a little bit random. Seek and false loop is false. Okay, cool. We didn't evaluate loop. And if I say true, okay, sure. True. Should be truance. What? Funny typo. Actually I get a arrow for. So this is because they didn't. So yeah, because they have these dots here. It is kind of funny. Maybe I can write down the typos I find in the thing and then give it to them in one go. I'm gonna write it down here. I don't know why Qt browser doesn't. Why does it not give me a copy sometimes? Here I can copy, but here not. Okay. But I can use this button. Okay, so here's a typo. Okay. Apparently in the proposed setting, the first argument should be evaluated, so its type should be bool, while the second argument should be shouldn't be immediately. What will be the whole solution? Yeah, this is this. I'm proud I solved a small puzzle. Okay, transforming expressions. Yeah, exactly. Yeah. Because so far I have basically sort of said whether to evaluate something or not, but I mean it would be cool if we now do something with the expression as well. Swap arguments. Okay, one may want to use atom type arguments not only for just avoiding computations or quoting expressions, but to modify them before evaluation. Let us consider a very simple example. With swapping the arguments of a function, the code below will give -7 as a result. Okay, colon, swap, arguments, atom is a function that takes an atom and returns an atom. Okay, so this basically, we already see it kind of takes an expression, returns an expression, kind of makes a transformation on an expression, probably. Or that's what we are about to go for. So who's $op, then arg1, $arg2. So yeah, and now you return a new expression. new expression with this is swapped. Okay, evaluate swap arguments. Oh, this is complicated. I'm gonna say, so I need something like, so minus 15 minus 8 is 7, and 8 minus 15 is minus 7. So basically we end up evaluating the swapped thing. Okay. Also extremely straightforward. Nothing needs to be quoted, blah blah, like this. It's cool how little you do there, yeah. I guess these expressions and these patterns are somehow the stuff that we code with. It's like yeah. In Lisp we code. The code are lists, and we use our program to modify the lists. Yeah, and here it's very similar, but these equalities are allowed to simply return new expressions. I'm not entirely sure, but yeah, making this the same thing as a normal function. It's making it one simpler somehow. Yeah, it's interesting. Yeah, you see that you can probably do very complicated stuff that still looks, or you can do very complex things in a simple way, I think. They really deliver on this meta programming thing. That's for sure. Let's see. At the same time, the same code without typing would not work. Yeah. Without this atom, this would be a function. Yeah, it would return. It would just return. Wait. They say here it would. So it would return. Yeah. It would reduce this to 7 and then try to call a function with 7, or try to find the equivalence with 7, and then nothing would unify, and it would just return this function with 7. Like, it's just like if I would say here foo, this should be foo 7, then yeah. That's just. Yes. Okay, what is that? Swap arguments, op arg1, arg2, arg2, arg1. So that is without typing, yeah, okay. One more example of using the atom type is comparing an expression. Yeah, I see. Okay, comparing. That is that atom EQ returns true when arguments identical can be unified with the same variable. Let me type this. Okay, so make a function called atom EQ. That's a function that takes an atom, another atom, and returns a bool. Then I implement atom EQ, say $x, also itself. Oh man, this is so cool. Also, yeah, we automatically use the unify functionality, kind of, sort of Implicitly, yeah. Atom EQ. Oh yeah. Okay, this is cool, yeah. And I just I just say things are cool every 20 seconds. Oh yeah. Yeah, because nothing unifies where there are two X's here. Yeah, okay. Where am I now? I'm basic types and meta types, controlling pattern matching. Okay. Controlling pattern matching. Both standard and custom functions in meta can have atom-typed arguments, which will not be reduced further which will not be reduced before these functions are evaluated. But we may want to call them on a result of another function call. But we may want to call them on a result of another function call. So you kind of want to force evaluation sometimes, I guess, or something. What is the best way to do this? Before answering this question, let us consider the match. Let us consider match in more detail. The type signature of the match function. Pattern matching is the core operation in MeTTa, and it is implemented using the match function, which locates all atoms in a given space that match the provided pattern and generates the output pattern. Let us recall that the match function has three arguments: a grounded atom referencing a space, a pattern to be matched against, output pattern, and an output pattern. So if I say evaluate get type of match, I would see that it takes a space, an atom, and its return type is undefined. Okay, so anything. Okay, that's how it works. The second and the third arguments are of atom type. Thus, the input and the output pattern are passed to match as is without reduction. Yeah, exactly, yes. But maybe sometimes I want the result of a function to be passed to the match. Exactly, yeah. That would be useful. Preventing reduction of the input pattern is essentially needed for the possibility to use any pattern for matching. The output pattern is instantiated by match and returned, and only then it is evaluated further. Yes, the output pattern as well. Output pattern also is not evaluated. It is only evaluated later on. This is the return type. The return. Yeah, it's the return. One sec. This is the return. Yes, you say an output pattern, and the type of the output pattern in the end is undefined. But yeah, it kind of returns you this filled in, this thing that you pass filled in. In an own behavior of match, the following example: green $who is evaluated to true for who bound to Todd due to the corresponding equality. Okay, I type green Sam. Then I type equal green Todd true. So there are kind of two ways of saying green a little bit. Evaluate $who green who. Wait, why does this say Todd? Todd true? Wait, one sec. Green who? Doesn't this say basically who is Sam? No. It says so it wait. So, wait one sec. Okay, yeah, this is something I still need to. So when the evaluator looks at this part, it basically looks at this as a function call, then it evaluates the arguments. So it goes and tries to evaluate this. So it basically goes into the current atom space and roughly does the equivalent of this here. Where it basically says, is there any equal sign that I can... Is there any equal sign thing expression in the atom space with this argument here? And that says true. So... Yes. So this is the first argument to the function here. So it comes out to this... But who is also bound now to Todd? It's a little bit more sophisticated than just saying true $who, right? What does this do actually? No, okay, this leaves who unbound, okay. It also does say that who is Todd now. Okay. So maybe this is this does it do what if I unify with the space and that would be green who result. Here I return something like that, right? Who? And here with result. I think this would basically be an else fail, you know. Yeah. This would return Todd true, the same way that running it here returns Todd true. Yeah, I'm guessing that roughly this is happening, but how it basically does that, I guess it evaluates, or it tries to evaluate this part, but it sort of doesn't forget about the who. And maybe it actually what it does is that it basically comes out to this part. Oh wait, it comes out to... But it can't throw away the... Oh wait. Yeah. I don't know. I just wanted to write here, but this doesn't make sense. Yeah. It must do the equivalent of this computation. This is I'm more or less certain, because it must sort of keep track of the who in order to be able to say Todd true. Oh, yeah. Okay, this was just as an aside. Yeah, and this didn't have anything to do with Green Sam, because we didn't ask for any pattern Green Sam. We asked for evaluating sort of the function green. And got a true out. So something like that happened. Okay. Okay, so now the other thing where we get Sam, that is when I say match self green who, so this would match this part. And then I say dollar who, yeah, this would just be Sam. Green who is just a pattern. We pass the pattern green who here. Because the type signature of match atom. Green who is not reduced when passed to match, and the query returns Sam without utilizing the equality because green Sam is added to the space. Let us verify that the result of match will be evaluated further. Let us verify that the result of match will be evaluated further. So yeah, that's I know that. I mean, I could say here evaluate, make an equality Sam foo, right? Just this, and now I would get. Oh wait. Oh, do I need to say it? So I guess I need to say this. No. Wait. What? I thought I can get a foo here, no? Something I'm not doing correct. Let's see what they do. Match first finds 2 entries satisfying the pattern green who. So that's Sam and Todd. And instantiates the output pattern on the base of each of them. So frog. Also yeah, frog. Sam Todd. It tries to do frog Sam Todd. Then one. Okay. And the Sam one becomes true, and the frog Todd one just becomes unreduced. Okay, let's do this part. Okay, green Sam, green Todd. Then I define a equality of frog Sam true. Then match self green dollar who. This is both the green people. I can also write here who like this. See, there's Todd and Sam, and now I can basically also code with this who a bit further, kind of. It will be evaluated. Frog Todd true. Yeah, alright, okay. We can verify that instantiation of the output pattern happens before its evaluation. Okay, let's quote. What does this do? It should return frog who. Right? It should return quote frog who. Wait, it's filled in. Oh, yeah, okay. Now I get it, what they mean. Yeah, it's filled in, exactly, yeah. It is filled in, yes. So the expression was, or this pattern was filled in with stuff that is called instantiation of output pattern, okay. So filled in with stuff, so it says quote frog Sam, yeah, and now I return quote frog Sam, because that's what quote is doing. It returns all the expressions without reducing them and putting a quote in front of it. Here, green dollar who is matched against green Sam. Yeah, $who gets bound to Sam and then is substituted to the output pattern yielding quote frog Sam, in which frog Sam is not reduced further to true because quote also expects atom. Yes. Thus, match can be thought of as transformation of the input pattern to the output pattern. It performs no additional evaluation of patterns by itself. Yeah, but now maybe we would want to do that, I guess, sometimes. Or returning output patterns with substituted variables before further evaluation is very convenient for nested queries. Aha. Right. Okay, green, Sam. Likes, Sam, Amy. Likes, Todd, cut. Okay. Evaluate the spots. Then I say evaluate match, ampersand self, green, $who. So anybody that is green. Okay, this is Sam at the moment. It's actually also tall for me. Okay, and then return an output pattern. Okay, and here I do match again. But basically this is not evaluated or anything. This is just basically being filled in as output pattern. So I'm sort of coding with expressions here right now, and basically I'm imagining what do I fill in. I fill in a who, and $x is not substituted with anything. So this basically says who's green and likes somebody else, and that somebody else is the X. So this is cut and Amy. Cut and Amy. Fug? Achso, Todd, yeah, I have Todd. Todd is also green for me. Maybe I make a third likes here, like Bob. Bob also likes cat. And you see, I get cat and Amy. Achso. Okay, I'm gonna say Albert. Albert likes Matilda. Okay, so Matilda doesn't show up here because nobody that is green likes Matilda. Yeah, there is nobody that is green that likes Matilda. That's what it's saying. Okay, what else can I do now? I can say here boo instead, and now it just doesn't matter. The who is just thrown away basically, so this just doesn't. It's like not using it at all, but I think I get this twice because I have two green people, so I get everything twice, and that is everybody that likes anybody else. So I think I should get four times 2, 8 outcomes. Yeah, I get cut, Amy, Matilda, cut, Amy, Matilda. Yeah. Because for everybody that was green, I evaluated this query, and this query just says, give me everybody that likes, and that is called boo, somebody else, and that is called X. Yeah. Okay, cool. Match, ampersand self, likes, $who X. Okay, everybody that likes somebody else, who likes X, match, ampersand self, green, $x. So find everybody that likes anybody else, take that X and ask and then in the second evaluation call match again, where now X is substituted in with these people. Amy, cut, Matilda. But there's nobody that is green, so this should just say nothing. Yeah, it says nothing. Okay, then match $self likes ampersand self, sorry. $who, $x, match, okay, self green boo boo. Yeah, okay, this is a little bit silly. I get all the green people 4 times, right? So I get 8 green people again. 8 green results. Okay. That's how it looks. The output of the outer query is another query. The inner query is not evaluated by itself, but instantiated as the output of the outer query. In this case, $who gets bound to Sam. Okay, yeah, but I'm not gonna go through that right now. I think I already was thinking through it. In the third case, and these, and so forth. Okay. And then sometimes things are evaluated twice, because that's here, for example, a case for me that I have 2 green people, so this will happen twice. Patterns are not type checked. Functions with atom type parameters can accept atoms of any other type, including badly typed expressions, which are not supposed to be reduced. As it was mentioned earlier, this behavior can be useful in different situations. Indeed, why couldn't we say, quote, a badly typed expression as an incorrect example? Why couldn't we say, quote, a badly typed expression as an incorrect example? What? But yeah, it like it would make sense to me if I take an atom, or if I take expressions as inputs, then I don't really understand why including badly typed expressions. So this also makes a lot of sense, because how am I supposed to work with expressions? Maybe I want to exactly check something about the type of the expression. Yeah, this would be very restrictive if I could only work with proper typed expressions or something like that. That would be strange, yeah. Because I want to meta program with the expressions, so that there should also be intermediate expressions and blah blah, so things like that. It should be noted, though, that providing specific types for function parameters and simultaneously indicating that the corresponding arguments should not be reduced could be useful in other cases. So yeah, okay, that you want to mix the two things, but you can always say get type on the expression that you have, right? And then do something with that. Like if I make a function called bool checker, right? I mean, this is silly now, but okay, it's some okay. It's training for me. Okay, so this is a function text, and atom returns a bool, and it returns true or false whether the atom, the input, has the type bool. So now I say I implement this, and that takes one argument, and now it says get type equal to bool. Does this work like that? One sec, I can check if that works like that interactively. Get type of true. I need to evaluate that, of course. Oh, so evaluate this. True. Okay. I'm guessing this is basically implemented correctly. Okay, bool checker and this. So if I say bool checker of type false, evaluate true. Okay, 2 times because I have it 2 times. And bool checker of plus 11, just false, without, and yeah, and but also something like this, nothing, right? So yeah, just so nothing Yeah, nothing. Didn't I want to say, yeah, I don't know how to say false. No. I think maybe this would work. No, doesn't. Okay. But yeah, this is a macro, or like a thing that operates on an expression, even if the expression is just false. But it also kind of talks about the type of the expression, right? So you can do that by just calling get type in your function, right? I could say if it's bool, then I say yes, and else I say no, right? Yeah. So now I say yes, no. And this is still nothing. Actually, why is this nothing? This is because get type of this is then nothing. This is an error. Can that be? No, it's nothing. Interesting. Then there's also no outcome. If I have anything in my evaluation tree that is nothing, I also don't have any outcome. This is something I didn't know. I didn't know about that yet. Okay, man, there's so much I don't know. At the same time, match is a very basic function, which should not be restricted in its ability to both accept and return incorrect expressions. Thus, one should keep in mind that match does not perform type checking on its arguments, which is intentional and expected. Yes, because I want to have intermediate expressions, of course. The following program contains a badly typed expression which can still be pattern matched, and match can accept a badly typed pattern. Yeah, so nobody says anything wrong about something like this, even though this is a grounded symbol that would for a type error. You can also match for this, yeah. And you could, in some way, you could literally look in the program for badly typed expressions or something like that, as well, or something. $x, $x. Also, yeah, I also get false here, yeah. Being that false, that comes out here as being pattern matched. Can be useful to deal with wrong meta programs on a meta level in meta itself. It can be useful to deal with wrong meta programs on a meta level in meta itself. So this behavior of match allows us to write code that analyzes badly typed expressions within meta. Yes, exactly. Yes, exactly. Yes. Or I want to build them intermediately or something. The type of equal. Type of equal. Meta programs typically contain many equalities, but is there a guarantee that the function will indeed return the declared type? This is achieved by requiring that both parts of equalities are of the same type. Okay, consider foo is a function that takes a number and returns a bool. Then I say I implement foo with x, and this is basically just an error or something. It's just I'm implementing a version of X that doesn't actually correspond to the type checking. Get type foo of X. It's also interesting. I can put a variable there and I say this is bool. Yeah, because X is of type undefined, I think. So it unifies with number. I think this is kind of like how this works. This says bool, and then now we say get type of plus $x and 1, and we get number. And now I say get type of equal, and that is t, I think, right? We already saw that at some point. Yeah, it's a function that takes a t and another t of the same type and then returns a atom, yeah? And then I say evaluate get evaluate equal foo. Wait, what? So wait, this is this equal. I was kind of thinking about the. I was thinking about the equal, but no, we talk about equal here. Ah, that needs the same type left and right. The fuck? Why is this like that? Maybe they will explain this. So foo $x, that has the type, we already saw it has the type bool. And plus x1, that has the type number. So this would be an error, that type. Yeah, but equal, evaluate equal. Yeah, exactly. I didn't know that evaluate equal does anything useful. Yeah. That is what's surprising me right now. I didn't know that was something. But yeah, equal also has a type where the left and right needs to be the same. And that's usually an expression, right? Usually left and right are expressions. So, but I can. Okay, this is probably fucking crazy, but so maybe I take a string here. I say that foo and foo2 are equal. Yeah, this is something I can do. Okay, yeah. So now foo is a little bit like a function. Like this? No. Like this? No. Do I need to say this? No. I thought I get foo2. I don't know how to get foo2. Foo? No, this doesn't think that foo is a symbol. Okay, why do you ever do anything else but expressions or symbols, I suppose, for this equal thing? That is I don't understand that right now. Her, so, but I can evaluate. Can I not evaluate? Or do I need, no. That's not how it works. You don't put symbols there, you put, okay, now I finally got my food too. Yes, I'm surprised that this would ever be something interesting, but yeah, in this case it throws an error because that has, yeah, they have two types. We declare the type foo to be number bool on the same on the base of this definition. The type foo $x can be reduced to bool, yes, which is the expected type of its result. However, the type of its body plus $x1 is reduced to number. If we get type of equal, we will see that both its arguments should have the same type. The result of type equal is atom. Since it is not a function unless someone adds an equality over equalities, which is permissible. The result of equal is atom. Since it is not a function. Okay. Unless someone adds an equality over equalities, which is permissible. In that case, equal becomes a function. If one tries to execute this equality, it will indeed return the type error. Programs can contain badly typed expressions, as we discussed earlier. However, this may permit badly defined functions. Aha. Okay. You evaluate pragma, type check, just kind of special language to talk to the interpreter, I suppose. Okay. Type check auto returns an empty thing. Okay, so now I say foo number bool. Now without evaluating this. So this would basically be an expression in the program. This equal, and now somebody will say error here. Okay, so that you would catch now. Okay, so this is basically when you write meta code, you can say that for all the functions I write, more or less, or something like that, please throw errors if I accidentally type the wrong types. And this is type check. Okay. This pragma option turns on type checking of expressions before adding them to the space without evaluating the expression itself. I can also. What if I say, yeah, I can say equal. Yeah, foo 10. This would also be an error, right? Because I said bool. I said it returns a bool. Yeah, also I have the wrong number of arguments, so it's just wrong in multiple ways. Okay, bad type. This is good. If I say true here, this is allowed. Okay, and I'm guessing that this is also not allowed. Okay, yeah, good. Yes. Okay. Sehr gut. Let. Come to the let binding after days and hours.